when dealing with a building that has two services as per section 230.2 C of the National Electrical Code, where both service disconnects are fed from a single power company transformer, several key aspects must be considered regarding bonding and grounding to ensure safety and code compliance. Firstly, with the main bonding jumper installed at each service disconnect and a 4/0 bonding jumper connecting the equipment grounding conductor buses in each disconnect, the initial question is whether this setup meets code. The answer is yes, it does comply with the National Electrical Code. Secondly, concerning neutral current flow, the presence of the 4/0 bonding jumper between the equipment grounding conductor buses will indeed result in neutral current flowing through this conductor between the two service disconnects. This is because the neutral conductor is bonded to the equipment grounding system at each service disconnect, creating parallel paths for neutral current. Thirdly, if both service disconnects were bonded to the same building steel, a similar situation would arise. Neutral current would flow through the building steel between the disconnects, essentially using the steel as a parallel neutral conductor. However, the 4/0 bonding jumper offers a more controlled and lower impedance path for this neutral current compared to the building steel. This lower impedance helps to reduce the amount of neutral current that might otherwise flow through the building steel, minimizing potential issues such as voltage drops or unwanted current flow in structural components. It's crucial to understand the role of the main bonding jumper at each service disconnect. This jumper serves to bond the neutral conductor, the equipment grounding conductor, and the grounding electrode conductor together. This bonding is vital for providing a low impedance path for fault current to flow back to the source during a fault condition. By ensuring a low impedance path, the overcurrent protective devices such as circuit breakers or fuses can quickly and effectively clear the fault, minimizing the risk of electrical shock or fire. Furthermore, the main bonding jumper helps to prevent the accumulation of static charge on equipment, which can be particularly important in certain environments. The purpose of the 4/0 bonding jumper between the equipment grounding conductor buses in each service disconnect is to equalize the potential between the two service disconnects. This equalization is intended to minimize the flow of neutral current through the building steel. By providing a dedicated, low impedance path between the disconnects, the majority of the neutral current is directed through the bonding jumper rather than the building steel, which is a less controlled and potentially higher impedance path. To elaborate on the grounding and bonding requirements, consider the specific sections of the National Electrical Code that pertain to these installations. Section 250.24 B addresses the grounding of the secondary system, requiring the neutral conductor to be grounded. Section 250.28 outlines the requirements for main bonding jumpers, specifying their size and installation. Section 250.30 covers grounding separately derived alternating current systems, which can be relevant in more complex setups. In the context of multiple service disconnects, it's essential to ensure that each disconnect has its own grounding electrode system, as described in section 250.50. These grounding electrodes must be bonded together to form a grounding electrode system, ensuring that all service disconnects are effectively grounded. The size of the grounding electrode conductor is determined by section 250.66 based on the size of the service entrance conductors. The bonding jumper between the equipment grounding conductor buses, as discussed, is not explicitly covered in the same manner as the main bonding jumper. However, its application is based on the principle of creating a lower impedance path for fault current and minimizing neutral current flow in unintended paths. The selection of a 4/0 conductor for this bonding jumper is likely based on engineering judgment and considerations of the available fault current and the desired impedance. To further illustrate the concept, consider a scenario where a fault occurs on one of the service disconnects. The fault current will flow through the equipment grounding conductor back to the source, which is the transformer. The main bonding jumper at the service disconnect provides a low impedance path for this fault current to flow back to the neutral conductor and ultimately back to the transformer. The 4/0 bonding jumper between the equipment grounding conductor buses helps to ensure that the fault current has a clear path, regardless of which service disconnect the fault originates from. Without this bonding jumper, the fault current might be forced to take a less direct path, potentially involving the building steel or other metallic components. This could lead to increased impedance, slower fault clearing times, and a greater risk of electrical shock or fire. In addition to fault current considerations, it's important to address the issue of neutral current flow in more detail. Neutral current is the current that returns to the source via the neutral conductor. In a balanced three-phase system, the neutral current is ideally zero. However, in reality, unbalanced loads and nonlinear loads can cause neutral current to flow. When multiple service disconnects are present, the neutral current can divide between the different paths available, including the neutral conductors, the equipment grounding conductors, and the building steel. The goal of proper bonding and grounding is to control the flow of neutral current and minimize its presence in unintended paths. By providing a dedicated, low-impedance path for neutral current, such as the 4/0 bonding jumper, the amount of neutral current flowing in the building steel can be reduced. This is important because neutral current flowing in the building steel can cause several problems, including voltage drops, interference with electronic equipment, and increased risk of corrosion. To summarize the key points, the installation of a 4/0 bonding jumper between the equipment grounding conductor buses and multiple service disconnects fed from a single transformer is a code-compliant and effective way to minimize neutral current flow in the building steel. This bonding jumper provides a low impedance path for fault current and neutral current, helping to ensure the safety and reliability of the electrical system. While bonding to building steel can also provide a path for neutral current, the dedicated bonding jumper offers a more controlled and predictable path, reducing the risk of unwanted consequences. The National Electrical Code provides detailed requirements for grounding and bonding, and it's essential to consult these requirements to ensure that all installations are code compliant. The principles discussed here are applicable to a wide range of electrical systems, and understanding these principles is crucial for electrical professionals and anyone involved in the design, installation, or maintenance of electrical systems. Furthermore, it's worth noting that the specific requirements for grounding and bonding can vary depending on the local jurisdiction and the specific type of electrical system. Therefore, it's always important to consult with a qualified electrical inspector or engineer to ensure that all installations meet the applicable codes and standards. The information provided here is intended for educational purposes and should not be considered a substitute for professional advice. The proper installation and maintenance of electrical systems require specialized knowledge and skills, and it's essential to seek the assistance of qualified professionals when working with electricity. Now let's delve deeper into the technical aspects of grounding and bonding in multiple service disconnect installations. Grounding refers to connecting the electrical system to the earth, providing a reference point for voltage and helping to stabilize the system. Bonding refers to connecting various metallic parts of the electrical system together, creating a low impedance path for fault current. The combination of grounding and bonding is essential for ensuring the safety and reliability of the electrical system. In a multiple service disconnect installation, each service disconnect must have its own grounding electrode system, as mentioned earlier. This grounding electrode system typically consists of one or more grounding electrodes, such as ground rods, ground plates, or underground metallic water pipes. The grounding electrodes must be bonded together to form a grounding electrode system, ensuring that all service disconnects are effectively grounded. The size of the grounding electrode conductor, which connects the grounding electrode to the service disconnect, is determined by Section 250.66 of the National Electrical Code. This section provides a table that specifies the minimum size of the grounding electrode conductor based on the size of the service entrance conductors. The bonding jumper between the equipment grounding conductor buses, as discussed, is not explicitly covered in the same manner as the main bonding jumper or the grounding electrode conductor. However, its application is based on the principle of creating a low impedance path for fault current and minimizing neutral current flow in unintended paths. The selection of a 4/0 conductor for this bonding jumper is typically based on engineering judgment and considerations of the available fault current and the desired impedance. In addition to the bonding jumper between the equipment grounding conductor buses, it's also important to ensure that all other metallic parts of the electrical system are properly bonded. This includes metallic conduits, enclosures, and equipment. Bonding these metallic parts together creates a low impedance path for fault current, helping to ensure that overcurrent protective devices can quickly and effectively clear faults. The requirements for bonding metallic parts of the electrical system are outlined in Section 250.92 of the National Electrical Code. This section specifies the methods and materials that must be used for bonding, as well as the minimum size of the bonding conductors. When multiple service disconnects are present, it's particularly important to ensure that the bonding is continuous and that there are no breaks or discontinuities in the bonding path. This can be achieved by using bonding jumpers to connect the metallic parts of the electrical system together. In addition to the technical requirements for grounding and bonding, it's also important to consider the practical aspects of these installations. Grounding electrodes should be installed in locations where they will be in contact with the earth and where they will not be subject to damage. Bonding jumpers should be installed in a manner that protects them from physical damage and corrosion. All grounding and bonding connections should be made using approved methods and materials, and they should be regularly inspected to ensure that they are in good condition. Finally, it's important to remember that grounding and bonding are just one part of a comprehensive electrical safety program. Other important aspects of electrical safety include proper wiring practices, overcurrent protection, and regular inspections and maintenance. By following all of these practices, it's possible to create a safe and reliable electrical system that protects people and property from the hazards of electricity. Now consider a specific example to illustrate the principles discussed. Suppose a building has two service disconnects, each rated at 200 amps. The service entrance conductors are 4/0 copper. According to Section 250.66 of the National Electrical Code, the minimum size of the grounding electrode conductor for each service disconnect is number 6 copper. The grounding electrodes are ground rods, and they are installed in accordance with Section 250.53 of the National Electrical Code. The main bonding jumper at each service disconnect is sized in accordance with Section 250.28 of the National Electrical Code. The 4/0 bonding jumper between the equipment grounding conductor buses is installed to equalize the potential between the two service disconnects and minimize neutral current flow in the building steel. All metallic conduits, enclosures, and equipment are bonded in accordance with Section 250.92 of the National Electrical Code. The electrical system is inspected regularly to ensure that all grounding and bonding connections are in good condition. In this example, the grounding and bonding system is designed to provide a low impedance path for fault current, minimize neutral current flow in the building steel, and protect people and property from the hazards of electricity. The system is code compliant and meets all applicable safety standards. By following these principles and practices, it's possible to create a safe and reliable electrical system in any building with multiple service disconnects. Remember to consult with a qualified electrical professional to ensure that all installations meet the specific requirements of the location and the electrical system. The National Electrical Code is a complex and comprehensive document, and it's essential to have a thorough understanding of its requirements to ensure that all electrical installations are safe and code compliant.